My name is Albert Einstein. I was born on March 14th, 1879 in the city of Ulm in Germany. When people hear my name today, they often think of genius complicated equations and the famous formula E equals mc2. But my life was not always easy or extraordinary from the beginning. In fact, as a child, I was quiet, curious, and sometimes misunderstood. My parents, Hermann Einstein and Pauline Einstein, were not scientists. My father was an engineer and a businessman who worked with electrical equipment. My mother loved music, especially the piano, and she encouraged me to learn the violin. Music later became one of the greatest joys of my life. When I was very young, something happened that changed my way of thinking forever. My father showed me a simple magnetic compass. I was amazed that the needle always pointed north, even though I could not see any force acting on it. That small compass awakened my curiosity about the invisible laws of nature. I realized that something mysterious governed the world around us. As a child, I did not fit well into the traditional education system. My teachers expected students to memorize facts and follow strict rules, but I preferred to think deeply and ask questions. Because of this, some teachers believed I was slow or rebellious. In reality, I simply wanted to understand how things truly worked. When I was about 10 years old, I discovered mathematics and science books that fascinated me. Geometry especially amazed me. The certainty and logic of mathematics felt like discovering a perfect language for understanding reality. From that moment, my interest in science grew stronger every day. My family later moved to Munich, where I attended school. However, I struggled with the rigid discipline of the German education system. Eventually, my family moved to Italy for business reasons, and I left school in Germany to join them. This was a difficult period in my life, but it also gave me freedom to think independently. Later, I enrolled in the Swiss Federal Polytechnic in Zurich, a respected institution where I studied physics and mathematics. My goal was simple. I wanted to understand the laws that govern the universe. University life was exciting but also challenging. I often skipped lectures that felt repetitive and instead studied scientific papers on my own. I was especially inspired by the works of scientists such as Isaac Newton and James Clerk Maxwell. Their ideas about gravity, motion, and electromagnetism shaped my understanding of nature. After graduating in 1900, I struggled to find a teaching position. Professors did not consider me an ideal student because I questioned authority too often. Eventually, I found a job working at the Swiss Patent Office in Bern. At first glance, the patent office might seem like an unusual place for scientific discovery, but for me, it was perfect. My job required evaluating new inventions and thinking carefully about how machines worked. This work sharpened my ability to imagine complex systems. During this time, I spent my free hours thinking about deep questions in physics. I often imagined strange scenarios which I called thought experiments. One of my favorite questions was simple but profound. What would happen if I could travel alongside a beam of light? In 1905, my ideas finally took shape. That year became known as my miracle year. So I published 4 scientific papers that changed physics forever. The first paper explained the photoelectric effect, showing that light behaves not only as a wave but also as tiny packets of energy called quanta. This discovery later earned me the Nobel Prize in Physics in 1921. The second paper provided strong evidence for the existence of atoms, which at that time some scientists still doubted. The third paper introduced my special theory of relativity. This theory revealed something astonishing. Space and time are not fixed and absolute. Instead, they are connected and can change depending on motion. According to this theory, time can slow down and lengths can contract when objects move close to the speed of light. Perhaps the most famous result of this work was the equation E equals mc2, which shows that energy and mass are different forms of the same thing. Even a small amount of matter contains enormous energy. At first, many scientists found these ideas difficult to accept, but over time, experiments confirmed the predictions of relativity. Gradually, my work gained recognition in the scientific community. In 1915, I completed an even more ambitious theory called general relativity. This theory described gravity in a completely new way. Instead of being an invisible force acting at a distance, gravity became a result of the curvature of space and time caused by massive objects. Imagine placing a heavy ball on a stretched rubber sheet. The sheet bends and smaller objects roll toward the center. In a similar way, stars and planets bend space-time, causing other objects to move toward them. This elegant idea explained many astronomical observations. In 1919, during a solar eclipse, scientists tested my theory by measuring how light from distant stars bent as it passed near the sun. The results confirmed my predictions. Overnight, newspapers around the world declared that a new scientific revolution had begun. Suddenly, I became famous, but fame was never my goal. What truly mattered to me was the beauty and harmony of the laws of nature. Throughout my career, I continued exploring the mysteries of the universe. I worked on cosmology, trying to understand the structure of the universe itself. My equations suggested that the universe could expand or contract. At the time, I introduced a term called the cosmological constant to keep the universe stable, though later discoveries showed that the universe is actually expanding. During the 1930s, political changes in Germany deeply affected my life. The rise of Adolf Hitler and the Nazi regime made it dangerous for Jewish scientists like me to remain in the country. I decided to leave Germany and move to the United States. I accepted a position at the Institute for Advanced Study in Princeton, New Jersey. There, I continued my research and spent many years thinking about one final dream: creating a unified theory that could connect all the forces of nature. Although I never fully achieved that goal, the search itself was meaningful. During World War II, I faced a moral dilemma. Some scientists feared that Nazi Germany might develop atomic weapons based on the principles of nuclear physics. I signed a letter to the American president warning about this possibility. This action indirectly contributed to the development of nuclear weapons. However, after the war, I became a strong advocate for peace and nuclear disarmament. I believe that science should be used for the benefit of humanity, not for destruction. In my personal life, I remained a simple person. I loved walking, playing the violin, and thinking quietly about the universe. I often said that imagination is more important than knowledge because imagination opens the door to discovery. One of my deepest beliefs was that the universe is governed by elegant and understandable laws. The more we explore nature, the more we see its beauty and harmony. Even today, many technologies rely on ideas from relativity and quantum physics. GPS satellites, nuclear energy, and modern cosmology all use principles that emerged from my work. Yet I never considered myself a genius in the traditional sense. I simply remained curious. I never stopped asking questions about the universe. I once said, the important thing is not to stop questioning. Curiosity has its own reason for existing. As I look back on my life, I realize that every discovery began with a simple question and a deep sense of wonder. Thank you.